Okay, so number one, complete the table and state the domain and range for the sequence it represents. So this is an arithmetic sequence, and it looks like our common difference is 2, right? We add 2 every time, plus 2. Okay, so that means our third term, 7, we jump from 7 to 9, and then we jump from 9 to 11, and then we would jump from 11 to 13 on our fourth term, and then from 13 to 15 on our fifth term, 15 to 17 on our sixth term. So your domain is going to be your position values, and that would just be 1, 2, 3, 4, 5, and 6. That's your top portion, your position values. Your range is going to be the bottom portion, which is your, I guess you can consider your answer. So that would be 7, 9, 11, 13, 15, and 17. You have to identify the domain and range for these problems as well. So here it looks like our common difference is we're adding 15 every time. So from 30 to our next term, we'd have to add 15, which would be 45. Then we add 15 again, that would be 60, that would be our fourth term. We add 15 again, that would be 75, that would be our fifth term. We add 15 again, that would be 90, that would be our sixth term. Our domain is going to be your position values, which is 1, 2, 3, 4, 5, and 6. Our range is going to be 15, 30, 45, 80, 60, 75, and 90. So here we're asked to find the first 4 terms of the sequence. Well, if you notice, this sequence has that f of n minus 1, okay? And that's a big indicator that this sequence right here is going to be a recursive sequence. Okay, so because it's recursive, we need to know our previous terms in order to find our next term, right? So if we wanted to find the first 4 terms, we already have f of 1. It's right here, right? So how would we find f of 2? Well, it's going to equal f of 2 is going to equal 5 times, here we have that f of n minus 1. You need to remember that that whole thing means previous term, right? Because f of n minus 1 means it's f of 2 minus 1. 2 minus 1 is 1. That's your f of 1 right there. So you're not, what you're plugging in there was our previous term, which was 7. You're plugging in 7 there. You're not subtracting 7 minus 1. This whole thing means previous term. So you're just going to plug in 7. So it would be 5 times 7, and then this part right here, minus 7. Okay, 5 times 7 is 35. 35 minus 7 is 28. So we have to find the first 4 terms. So f of 3 is going to be 5 times, remember this means previous term, so our previous term, if we're doing f of 3, was 28. So we're plugging in 28, and then minus 7. So 5 times 28 is 140, and 140 minus 7 is 133. f of 4, which is the last one, would be 5 times your previous term, which is 133. That was our previous term, minus 7. 5 times 133 is 665, and 665 minus 7 is 658. Those would be your first 4 terms of this recursive sequence. Now this doesn't have f of n minus 1, so this is just an explicit rule. So if it was asking us for the 4th term, with explicits, we could just plug in 4, right? But it's not asking us for the 4th term. It's asking us for the first 4 terms. So even though this is explicit, we're still going to have to find f of 1, f of 2. We're going to have to find all of the first 4 terms, right? So let's start with f of 1. With explicit, we just plug in. So it would be 2 times 1 plus 4, which is 6. f of 2. With explicit, we don't care about our previous terms. We just plug in. So it would be 2 times 2 plus 4, which is 8. f of 3 would be 2 times 3 plus 4, which is 10. And f of 4 would be 2 times 4 plus 4, which is 12. Explicit, we don't care about the previous terms, we just plug in. Number 5, we're asked to find the fifth term of the sequence defined by this rule here. So again, if you notice, this right here tells me that we're dealing with a recursive rule. Therefore, we need our first term, which we have our first term. And in order to find the fifth term of the sequence, unfortunately, we're going to have to find f of 2, f of 3, f of 4 before we can find f of 5. How would we find f of 2? Well, remember, this means our previous term. If we're looking for f of 2, our previous term would be f of 1, which was 2. 2 minus 6, which is negative 4. How would we find f of 3? Again, this is our rule. So it's our previous term minus 4, so we're going to get negative 4 minus 6. I said our previous term minus 4. I meant to say our previous term minus 6. I'm sorry. And negative 4 minus 6 is negative 10. F of 4. This is our rule, so again, it's our previous term. If we're doing f of 4, our previous term was f of 3, right? So that would be negative 10 minus 6, which is negative 16. And last, f of 5. Again, this is our rule, so it's our previous term, which is negative 16, minus 6, which is going to be negative 22. That would be your fifth term in the sequence. This doesn't have f of n minus 1. It has n minus 1, but that's not the same thing as f of n minus 1. So therefore, this is going to be an explicit rule, which if we're looking for the fifth term, that makes this a lot easier because we could just go right to f of 5. We don't have to find any of the previous terms. That's going to be 1/2 times 5 minus 1 plus 11. Well, 5 minus 1 is 4, right? 4 times 1/2 is 2, and 2 plus 11 is 13. We don't need to find anything else. That's it. We're done. This is going to be a fifth term. F of 5 equals 13. Right? A recursive and explicit rule for each arithmetic sequence. You need to memorize these. These are not going to be written down for you tomorrow. So remember, recursive rule, I'll just put that with an R. Recursive rule is going to be f of n equals f of n minus 1 plus your common difference, whatever that is. And for your explicit rule, that's going to be f of n equals your common difference times n minus 1 plus your first term f of 1. So for number 7, we need our common difference. We need our first term. What's our common difference? Well, if you look at this, it looks like we're subtracting by 3 each time. So it would be negative 3. What's our first term? It's going to be 35. Okay, and remember that with recursive, for the equation part of recursive, we only need that common difference. So let's do recursive first. I'll put this in blue. So recursive will be in blue. Okay, so for recursive, it's f of n equals f of n minus 1. That doesn't change. It's always going to be like that. The only thing that's going to change is that plus d. Because our d is negative 3, it would be minus 3. And on the side or on the bottom, remember, go ahead and define f of 1 because with recursive, you need f of 1 in order to solve it once you start solving this. But that's not part of your equation, though. And then explicit, I'll do in green. So with explicit, we have our common difference and our first term. So that's going to be f of n equals our common difference, which was negative 3, times n minus 1, plus our first term, which is 35. That's it. It's just asking you for a recursive rule and an explicit rule. It's not asking you to find a specific term. So you would just leave it like that. Number 8, same situation. Let's go ahead and identify our common difference. Our common difference, once again, is going to be negative 2. And let's go ahead and identify our first term. Our first term is going to be 112. Let's do our recursive first. So recursive is always going to start with f of n equals f of n minus 1. That's not going to change. The only thing that's going to change is plus d. So that depends on what your common difference is, which in this case is negative 2, so that would be minus 2. and go ahead and label and identify your first term, because you need that once you're actually solving or working with a recursive rule. You always need your first term. And then explicit, I'll do in green. So for explicit, it's going to be f of n equals your common difference, which is -2, times n minus 1, plus your first term, which is 112. You don't need to do anything else with that. You're done. Number 9, it says to write an explicit rule in function notation for each arithmetic sequence. So go ahead and pause this and read through the problem. Then we'll work it out together. So if we look at our problem, it looks like our first term, f of 1, is going to be 38, right? That's right here. And our common difference, it looks like we're going up, right? And we're going up by 12 each time. So it's going to be a positive 12. That's our common difference. Now we have enough information to write an explicit rule. So the explicit rule would be f of n equals your common difference, which is 12, times n minus 1, plus your first term, which is 38. That's it. It's just asking for an explicit rule. It's not asking us to find any terms. Okay. Number 11 is asking us to find a specific term. Pause it, read through it, try to figure it out. All right. So number 11, here's a graph of the wolf population, and it shows how it's declining over a few weeks. So let's first identify our first term. Looks like our first term is right over here, which is 100. So let's go ahead and write f of 1 equals 100. What's our common difference? Well, we're going down, so our common difference is going to be negative. And it looks like we go from 100 to 94 to 88. It looks like we're going down by 6. We have enough information to write an explicit rule. That's going to be f of n equals your common difference, which is -6, times n minus 1, plus your first term, which is 100. But this time, though, it's asking us to find f of 9, okay, and explain what it represents. So f of 9, we're going to plug in 9 anywhere we see an n, would be -6 times 9 minus 1 plus 100. Well, 9 minus 1 is 8. 8 times 6, a -6 is -48. And -48 plus 100 is 52. What does this mean? This means that after 9 weeks, how many wolves will we have? 52 wolves. Make sure you're able to explain that on the test. It is a 3-part problem, number 12. So first it's asking for an explicit rule. So we need our f of 1, we need our first term, and we need our common difference, right? So pause it, try to figure this out on your own before you watch me do it. So what is our first term? Right there, that's 215. 215 would be our first term, right? Now, what's happening between weeks? What's happening between terms? It looks like we are adding, 26. 26, so our common difference would be 26. Now let's go ahead and write an explicit rule. So again, explicit rule, it's going to be f of n equals your common difference, which is 26. It's positive because we're going up, times n minus 1 plus your first term, which is 215. That's all you have to do for part A of this problem. So it says if Evor's ants have a mass, I'm reading part B now, I'm sorry. If Evor's ants have a mass of 1.5 grams each, what will be the total mass of all of his ants in 13 weeks? Well, first we need to figure out how many ants he's going to have in 13 weeks. How do we do that? We plug in 13. Anywhere we see an n, plug in 13 in that explicit rule that we just came up with. So it's going to be 26 times 13 minus 1 plus 215. So that's going to be 26 times 12 plus 215. 26 times 12 is 312. And 312 plus 215 would be 527. That's how many ants he has, right? He's going to have 527 ants. But we're trying to find the total mass of all of his ants. Each ant weighs 1.5 grams. So what should we do with 525 and 1.5? We should multiply it. That would give us the total mass of all of his ants. So if you multiply 527 by 1.5, you get your answer, which is 790.5 grams. That's how much his ants would weigh. Or I'm sorry, not weigh. That would be the mass of his ant farm after 13 weeks. When the colony reaches 1,385 ants, Ivor's ant farm will not be big enough for all of them. In how many weeks will the ant population be too large? So this time we're looking for the amount of weeks, and we're given the amount of ants. So this time we're given what f of n equals. We're looking for what n equals, right? So f of n is going to equal 1,385. We're looking for n, which stands for the number of weeks. We're going to use that same formula that we came up with in part A, that same equation, that we came up with in part A, which was f of n equals 26 times n minus 1 plus 215. But this time, I know what f of n equals. This right here, I want it to equal 1,385 because I want to figure out n. I want to figure out how many weeks it would take to get to that number, because then I won't have any more space, or not me, Ivor, or whatever person we're talking about in this problem. Okay, so we want to figure out how many weeks it would take for us to have this many ants. So we're just going to go ahead and solve this equation. Okay, how do we solve it? We first use a distributive property right over here. So that would be 26n minus 26 plus 215. So that if we combine like terms, we would have 1,385 equals 26n plus 189. Okay, now what would we do first? We would get rid of that 189 first by subtracting both sides by 189. And if we do that, we would get 1,196. And we would divide by 26 next. And if we divide by 26 on both sides, we would get n equals 46. So after how many weeks would we have 1,385 ants? 46 weeks. So your answer would be 46. That's it. All right, make sure you not only study the study guide and this video, but also the notes that we've done this week. And good luck on your test tomorrow. We'll see you tomorrow.